Hi, I'm Michael Pfeifer. This is another episode of Metal Conversations. In this episode, I will discuss product reliability. Reliability refers to the ability of a product to perform as needed for a period of time. Reliability is pretty important if you want people to buy your product and say nice things about your product, and to avoid recalls when there is a problem with reliability and safety is a concern. This podcast is a complement to the article Designing for Reliability and also a short video recording that's on our website. If you go to www.imetllc.com and look in the blogs, you'll see the Designing for Reliability article. So going back to the discussion here, a product can have poor reliability if it's constructed poorly. For example, I purchased an electric water kettle and the lid will not stay closed. Perhaps the lid latch is too small to properly engage with the kettle opening, or the lip of the kettle opening is too small for the latch to properly engage, or the latch mechanism is always pushing on the latch and causing the lid to pop open. In any case, it's an irritation, but I will continue to use the kettle and will just tell people to avoid the brand. Now, I'm not concerned with that cause of poor reliability. I'm concerned with reliability as it relates to how materials respond when exposed to use conditions. And the use conditions act on materials and can cause degradation of the materials, and these use conditions are referred to as stressors. Stressors include mechanical loads, surfaces moving against each other, corrosive environments, chemicals, heat and cold, electricity, and radiation. Now, there are different degradation mechanisms that can happen to materials, and those degradation mechanisms depend on the material and the particular stressors that are acting on the materials. And the degradation mechanisms include corrosion, wear, fatigue, creep, embrittlement, and loss of strength. Now, since all products consist of materials, it's important to understand the stressors acting on components and joints and how the materials respond. Now, there are many cases where some degradation is acceptable. For example, steel bolts with a zinc coating might undergo some corrosion during use, but not to the extent where the bolts fail. But it's a problem when a component or joint degrades to the point where it stops functioning as required during the normal life of a product. So the reliability of a product depends on the extent of degradation of the materials that make up the product's components and joints. And identifying the conditions to which materials are exposed and selecting materials that can withstand the exposure is a critical part of designing products that have good reliability. There are 5 sources of stressors. The first is the component functionality, or is related to the component functionality, which is related to the stressors directly related to a component's functions. Examples are the mechanical loads on a motor shaft as the shaft moves another device, and the electricity that passes through an electrical circuit. With the motor shaft mechanical loads, if they are cyclical, they can cause a fatigue crack to form and grow in the shaft, possibly leading to fracture of the shaft, and then the motor would stop working. The electricity that passes through a circuit can cause electromigration of the circuit metal, leading to an open circuit. The second source of stressors is the environment in which the component operates. Examples of environmental stressors are corrosive liquids and fumes that can attack equipment in processing plants, and high temperature environments that can cause plastics to soften or break down or cause metals to undergo phase transformations. For many products, the environmental conditions depend on a component's location within a product. A component located within the passenger compartment of an automobile is not exposed to the same temperature and corrosion conditions as a component located in the engine compartment. The pan of a skillet is exposed to much higher temperatures compared to the handle. The third source of stressors is interactions with other components, such as through contact with each other or when a component outgasses a chemical that interacts with another component. Examples of component interactions are gears wearing on each other as they move, and galvanic corrosion between components made of different metals. Other interaction stressors are wear, rolling contact fatigue, crevice corrosion, heating, outgas chemicals, and others. The next set of source of stressors is minor abuse. Minor abuse stressors are slightly excessive but expected stressors that occur during typical use of a product. Examples of minor abuse include dropping a telephone from a short height onto concrete, driving an automobile over potholes, and small chemical spills onto a motor. Many products are expected to withstand some minor abuse without failing to meet its performance requirements. Finally, there's misuse. This refers to stressors that far exceed those expected during typical use. Products are not expected to be designed to be able to withstand abuse. It's unrealistic to expect a cell phone to function properly after using it to hammer a nail into a wall or dropping it into a toilet, or expect a car to function properly after driving it through water that's 2 feet deep. So we use our knowledge of stressors as part of the material selection criteria for a component or joint. When we understand the material selection criteria, we can then identify the materials to use for a component or joint. The selection criteria for material includes the requirements for performance, reliability, cost, how the component will be fabricated, and also the component's size and shape. Quite often, we can easily identify a material that meets all the requirements if we understand all the requirements up front. So it's important to understand all the requirements, and for reliability, it's important to understand the stressors to which a material will be exposed and also the magnitude of the stressors. The magnitude can refer to the actual applied load, or the pH of chemicals to which components will be exposed, or the temperatures to which materials will be exposed. By understanding all that, getting all that information up front, we can then select materials that will be appropriate for an application. So identifying all the stressors acting on a component is critical for designing components that have the necessary reliability. The information is needed to identify the appropriate component form and the materials, and it's also needed to develop the product reliability testing necessary for verifying that the materials are suitable for the application. So going through the stressor identification process requires a solid understanding of how components are used and the conditions to which they are exposed. Failure modes and effects analysis is a great tool for helping to identify the critical components that require more attention and to identify all the stressors. And working with a materials engineer will help the process. So that's it for my discussion on reliability and understanding stressors. If you're interested in learning more, go to the Industrial Metallurgist website, www.imetllc.com, and look for the blog article titled Designing for Reliability. And as I mentioned earlier, it also contains a link to a video of a presentation about the same subject. If you haven't already, subscribe to the Metal Conversations podcast series to receive alerts for when new podcasts are released. You can subscribe on Spotify, Google Podcasts, Apple Podcasts, Apple Music, Pocket Casts, Overcast, Castbox, and Stitcher. Thanks again for listening, and good luck with your metals.